if you look at European Union, where there's like 220 million buildings that were built before 2001, and they are now being renovated at the speed of like 1% per year. There is also the kind of unknowing, like building owners don't exactly know what is the expected lifetime of a certain building.
Ville from Nobody Engineering, welcome to the Shit You Wish Your Building Did podcast.
Thank you.
You're very welcome. Super happy that you've joined us, because I think some of the stuff you guys are working on is really interesting. And maybe that's a good place to start. Tell us what you guys are doing.
So we are working to integrate, or we are building solutions to integrate legacy building automation systems to different real estate software solutions, applications from our partners. So trying to bridge the old world of old control systems from 80s, 90s, and early 2000s with things like energy optimization, indoor air quality optimization, demand response systems, and so on.
Okay. So, I mean, how would you, with your experience, how would you typify or describe the systems interoperability, integration that we see now? Like, what do you think the state of the market is regarding that?
Well, it's pretty challenging. So actually the way how our story began was we came from this semantic web digital twin side of things, and the world where we thought that this could be easily accomplished as a clean desk job.
And wrong you were.
Yeah, that's what we thought. And basically, we began working on this kind of a digital twin solution and integrating especially the building automation systems to this one platform for our pilot customer to look energy efficiency and things like that. We quite soon realized, I actually have some physical examples where we soon realized that, for example, this thing from the early 90s was a very common control system. I don't know if you ever heard Evensys. Yeah. So they basically bought, this is a Finnish system called Atmostech, but it was bought by Evensys, which then was bought by I think TA Systems or Schneider, but eventually it ended up in Schneider's hands. But those were very commonplace all over the buildings that we were trying to integrate. And what you're basically faced with is getting the data out is somewhat like possible using like a Modbus gateway in the IO bus of the building. But the minute you want to actually control the system and have like a scalable way of not only in beforehand deciding like one thing that you might want to control in the building, but actually have a full control over the automation system. That's when you start to have problems. And it actually isn't solved with new systems that well either. Like there's obviously, like everyone knows, BACnet and this kind of protocols, but they very often are actually designed to get data into the building automation system, but not really getting it out. So yeah.
Okay. So you're ending up with this kind of, I mean, and you kind of referenced, right, that client you were working with.
Yeah.
So you're ending up with these like different types of systems from different vendors. Some are old.
Yeah.
I mean, that one you showed, right? I mean, what would be the expected end of life for that?
That reached end of life a few years ago, and the next version of that is reached end of life the beginning of this year.
Okay.
So that's particular city-owned building operator that was managing the city-owned schools and hospitals and kindergartens and so on. It had something like 40-50% of the entire installed automation stock in this particular system at the moment it reached end of life.
Okay, and but I mean, as a customer, I mean that's not a great scenario to be in, right? Like, what's
it's especially now that we have like a shortage of skilled workforce to install new things. We have shortage of semiconductors, so we can't actually get the new control system. So when your kind of deferred maintenance backlog in terms of automation systems reaches a point that there isn't a vendor that could replace all of them at once, like that's a very difficult position. And now that we see the skyrocketing energy prices, now it's a kind of a tough spot for many, because that's not like energy optimization, like reducing energy consumption in a building is generally can be like, it's not really rocket science, as in you start to change the way the building is heated or cooled based on the amount of people there are. You might factor in things like the weather forecast or the amount of or the cost of energy or the production method of the energy and so on, and that what gives you easily 20-30% savings. And now that today in Tampere, where I'm living, the cost of 1 kilowatt is like 33 cents when it was, or my fixed term energy or electricity contract that is still valid until March is like 5 cents. So
wow, okay, massive increase. But I mean this is happening all over Europe at the moment, isn't it?
Yes.
Yeah, absolutely. And I mean, so you describe sort of the scenario with that client, why it's an issue. What are they supposed to do about that? Okay, so obviously we've got these increasing cost of energy. Also, and they, I guess, left with this scenario of like, okay, well, we've got this old system. Like, what are we going to do with it? Are we going to have to pay more, or pay to totally replace it?
Yeah.
Or what? Like, what are the scenarios for companies in that situation?
Yeah, well, that's kind of there's a bottleneck, and that's where we see our opportunity. Really, like that's when we realized the state of the industry in terms of how many legacy systems are out there. We regularly visit cities and towns and so on in Finland and elsewhere, where up to or more than 65% of the installed automation system base is already reached the end of life. So basically, all these cities are just sitting on a huge pile of deferred maintenance backlog, and they need to, in order, there's like 87 months until January 2030, when all of them are promised to be carbon neutral, and now you cannot get like a new CPU into a building automation system under 9 months. So that's like a lot. It's a very kind of challenging spot. So we pivoted our company. We changed the name, and we set up like the whole new vision. And we recently also raised some VC capital to solve this problem of integrating legacy automation systems with all these different service providers. So we are not ourselves providing energy optimization or any of that, but we are kind of like acting as a link or an integration platform between old systems and the software and system providers out there. We work with companies like Lassila, Tikanoja, and Tietoever, and so on, that are already like have a long experience in either energy optimization or real estate facility management.
Okay.
And in case of Tietoevry, for example, in this demand response market. And the way how we do it is basically using software robotics in a very kind of a unique way. So I can use this as again as an example. So you can see also behind me like a whole bunch of old CPU that are ticking there. But basically, even when it is very hard to integrate this into some cloud application with some gateway or something like that, there's always some way for an engineer to physically visit the site and then use some kind of a method for programming it and configuring it and understanding what's going on in the system.
Yeah.
So we had already some exposure to this RPAs or robotic process automation technologies, but we thought that, hey, this would be a very interesting new approach to use actually a combination of IoT and robotics to kind of fake the engineer and integrate into this system using the ways how the local engineer would use it. And actually, this is a slightly newer system from another Finnish manufacturer, but this is a freely programmable, basically like for smaller installations, so not just a huge site, but for maybe a building block or a small school or something like that. And the best way of kind of illustrate this is that you would, as an engineer, to understand, okay, what are the current set points and what are the measurements and so on. You would walk into the building, and then you would start to use this device here to kind of use this one button that you basically can use to navigate
and then
menus up and down and so on.
Yeah, and then they use that screen then to they see on the screen like the different menus.
They see on the screen all kinds of like things what's going on in the building. So we would then basically just a second, take the screen off. So you find that, hey, there is like this is a thing that like it connects to this thing via some kind of a connector.
Okay.
So we would then have this kind of this is an off-the-shelf 4G RS-232 gateway, which we would then basically just connect where the screen goes.
Okay.
And now what this system contains is the kind of the meat of our product, which is the different processes and kind of sequences of ways that what you could actually do with this thing, and it understands what information this is sending to the robot, and it can simulate what the building owner operator would do in this. In return, and the same thing then applies for pretty much like any old system. You can find these similar user interfaces from things like Trend and old Trend systems and so on. So that's kind of the core of the innovation, which is kind of shifts the point of where is most of the effort done. So when you are in a traditional integration setting, you would go into the building, you would find some kind of a cabinet where you have the CPU and then a bunch of I/O cards. You would install a gateway to the I/O line. Then you would try to find the documentation of what each of the Modbus registers in the I/O line actually mean, how you map them into the correct values. So for example, in case of this thing, there isn't actually the conversion from voltage or resistance to SI units is done programmatically on the CPU. So you cannot kind of read that data automatically as SI units from the I/O bus. So you would go there and you would have all this equipment, and then you would set it up per substation. It would take several hours, probably at least, to get the data reading happening. And then if you wanted to control something, let's say that you wanted from the cloud somehow send a signal to the system that, okay, turn off an air handling unit or something like that, you would need to then program it using the old tools into this system and send a message to your gateway from which this CPU could then read it. And that is so prohibitively expensive and time consuming that it's usually never done to start with.
Okay, and hence why you get into this scenario where you know, it's just stuff's just left there and no one does anything with it and it sits around and reaches end of life.
Yeah, and it's actually with, like, if you look at European Union, where there's like 220 million buildings that were built before 2001, and they are now being renovated at the speed of like 1% per year. There is also the kind of unknowing, like building owners don't exactly know what is the expected lifetime of a certain building. Is it going to be there for yet another 5 years or 10 years or 20 years or how long? So they are also very wary of upgrading systems in buildings that don't necessarily that might not last as long as the proposed lifetime or the useful lifetime of the new automation.
Yeah, okay. You don't want to waste money on investing in that new technology and then someone knocking the building down. Yeah.
So what we try to do is to make it so that, okay, if you have a building that has an old automation system and you are positive you are going to demolish it next summer, we want to create kind of a world where it makes perfect sense to integrate it into energy optimization system now, because you will save, I don't know, tens of thousands next winter before you demolish it next summer.
Okay, so even within that year, you can see some savings. Yeah, okay. Yeah, I think it's really ingenious way. I mean this what do you call it again? Robotic.
Yeah, well, there's the term is robotic process automation, RPA. But what kind of sets why we call it, or we use the term software robotics, because the RPA is a very kind of it's rooted in this, for example, financial sector and HR sector, where there's a role of RPA engineer or a consultant, which usually comes and sits next to some office clerk that is doing potentially repetitive work on their workstation, and they observe it for a while, and then they spot that, hey, every twice an hour you copy the PDF from that folder and then you add it to your SAP and you annotate it with this kind of information, and then you send an email. So here's a thing that we could automate, and then they make a robot, basically like a script that uses the user interfaces offered to this person to automate this particular task. So what is different from us is that compared to what we do, is that there's rarely is anyone there in this building, like a technical space, doing anything to the automation system. So the user interface or the operator panel of the automation system sits there year after year, and at most is used to change some schedule, like once a year during the Christmas celebrations or something like that in schools and so on. So we kind of repurpose this obsolete way of interacting with the old system to do pretty much everything on the system. So we are already done like integrating these old Atmos systems to platforms like Niagara. So where they are used either for real-time energy optimization or as this kind of a new supervisor, which is, by the way, another interesting topic is the way how these old supervisory PCs are causing like gray hair when they are running like end-of-life Windows versions and mining Bitcoin in some dusty cleaning closet.
Yeah, exactly. I mean, we talked about control, okay, so that's a way of like then being able to change the way and obviously make it much more efficient to control these older systems. What about data? I mean, are you able then to also be able to get data out to use in, let's say, some cloud application or data analytics platform?
Yeah, so yeah, we are basically, what the robot is doing is has these scheduled kind of tasks or jobs that it is on a clock, that every minute go and read all these values, read all the analog sensor values every minute, and read all the alarms every half a minute, and do these things with certain intervals, and then it pushes the data to the cloud. Obviously, we cannot get into the same kind of latencies and frequencies that you potentially could get with like proper I/O bus integration or something like that can hammer the system every 10 seconds, like every second or so. But this data is sent to a cloud, and then there we do our best to kind of normalize it. And we've done quite extensive research on the usage of brick schema, which is this ontology of building systems. And we have some good preliminary results on how we can kind of parse the data from the old automation system into this brick schema. And what kind of, well, takes an entire blog or a podcast episode to talk about the problems of labeling I/O points, and probably already had these kind of talks. But what is kind of interesting from our point of view in this data labeling, or how to make this kind of independent data layer where you would have semantically structured, like how the data, what the data actually means. So traditionally, you have these point lists. Basically, it consists of usually like the site identifier, and then some system identifier, and then some device name or device, like what kind of, is it a sensor, is it an actuator, and is it like a valve or a pump or whatever, and then perhaps like a position in a process, and that gives you this long string, which is then like varied in a million different ways in different buildings, and that's like site specific and year specific and country specific and vendor specific data, and only person that can reliably kind of decipher what's going on is the one who programmed it, and then the one who has spent years like working on the building. And that's quite often only thing that is left, that someone who is tasked to parse this data into some kind of a model, that's all they get. But what we are actually getting that is very rarely modeled in these automation systems is what it says on these menus. So we kind of get the contextual information. So there's like two different things going on in this system. There is how are the points called in the programming, and those follow these point label structures. And then there is, okay, what has the programmer tried to tell the user of this display? So we can use that as an additional kind of a hint, plus the understanding of the specific automation system. So they have certain types of categories of points to do certain things. So these are what helps us to normalize the data more than it would be feasible perhaps in some other scenarios.
Okay, that's awesome. And you're still working on that, and you're
Yeah, we're slowly working on that. Currently, our main customer base is both in the building owner side, but in terms of the service providers, we work with, let's say, on a traditional real estate companies that like would prefer their data in BACnet and can't really have, or currently still have no way of utilizing these models. So we are not pushing it. The situation is still pretty much the same that it was before, that there isn't actually that many companies and service providers that can fully utilize this brick schema data model to do something to the building. So it's not that there is a huge demand yet, but I can obviously see that in the future it's going to be a good thing.
Yeah. I mean, you should.
How by the way, you have a lot of discussions with different service providers. So how many companies or situations have you been where you really see kind of these semantic models being utilized in the kind of ideal way of what the promise is for them?
Oh, I don't know about like ideal way, but I certainly have seen examples of like companies, property portfolio owners who are using it and like have benefited from being able to normalize that data. But I agree. I mean, it's not every customer is the same, right? You've got people who are sort of like the higher end of things, and then more people who don't have the budget, struggling a bit. You know, they've got other problems just beyond normalizing data, right?
Yeah. What I've kind of noticed in this data normalization is that it is very hard to model an existing system to the finest of detail using any of the existing systems.
Okay.
So, for example, real estate core very much kind of gives you the high level overview of the assets you have, but it has very little ways of modeling the very complicated relationships that those assets have between one another in a building. So then it's very kind of you easily end up in a situation where you have nice looking things that actually fail to describe to the detail enough what's going on in the building that you could have an autonomous system that does some decision making over that.
Okay. Yeah. They're actually Brick and Real Estate Core are normalizing.
Yeah, I've read about that recently, that they create these things, and there's something going on with the BACnet as well, that somehow kind of that has some kind of a link to Brick as well.
Well, BACnet is sort of controlled, is not the right word, but it's part of ASHRAE. ASHRAE are the sort of the body that look after it, and ASHRAE are working on a standard I think, let me just get this right, 223p, I think, which is about this whole thing, and I think they want to create hopefully one. I mean, not that there needs to be just one data model, but that could well come out of those conversations.
Actually, the BACnet is very interesting in terms like we've done this kind of a divide and conquer type of way of solving the problems as they come, but we thought that, okay, well, if we come up with a way of getting the old automation systems integrated to our cloud, then we have all these MQTT and REST endpoints that we can throw around and everyone is happy. But then we actually realized very soon that, okay, there are our potential partners and service providers that use things like Niagara to then do something to that data, and it is awfully difficult to integrate like REST APIs in a scalable manner into these software systems that have been designed from the ground up, from this kind of a building engineer's point of view, and not from the cloud software nerd's point of view. So like it is easy for you to integrate a single REST API endpoint that gives you like weather data or something like that.
Yeah.
The minute you want to connect like 200 points in a building that all are in their own separate kind of REST routes, then it becomes like a nightmare for the system. So we couldn't get our data to the service providers. So we built this this kind of a reverse system where now we have actually Linux machines running in our customers' on-site premises in their network where the Niagara is situated. And we send the data from our cloud as MQTT to the customer's site, or to the customers, like the partner who is doing the optimization. We send it there. But on the Linux machine, we then create these virtual BACnet devices out from the data that are representing those things that the robots are controlling, and then those are kind of exposed in their internal network as like BACnet devices that actually don't exist, but looking at them, you see what's going on in the building, and if you make some change to it, that is translated into a message that then goes again via MQTT to our cloud, and from there to the robot that does the change. Okay. So that allows us to very efficiently get the data to the hands of the service providers. They know how to set up like a virtual machine or even like a Raspberry Pi in their internal network. That's what they know how to do. And then from there, you just have to press discovery on Niagara and you see all the stuff that we can bring to them.
Nice. Ville, I could talk to you all day. It's fantastic insight. And I know this is a super complicated subject, but thank you for describing it to us. I think my last question to you is, do you see the situation in 5 years changing? Like, what do you see coming down the road? We talked about normalization of data, but anything beyond that?
Yeah, well, I think that the way how the evolution of a building control system is going to be very interesting on how it's going to look like in a few years' time, especially when you start to go this data model first, describing actually not only always going from some internal data representation and struggling to convert it into this open and semantic model, but going and starting from the semantic model first and then building up from there. And but I think the systems are definitely going to get simpler. There is this saying that or many of these kind of an old school system vendors are marketing the automation system as the kind of a brain of a smart building, while I try to think, or I think it more as the kind of a lizard brain or the brain stem of the smart building. So it is supposed to keep it breathing, keep the like certain set of functionalities going on in the building, be easy to install, have as little semiconductors as possible, like having a compact and a simple system that you can easily upgrade and build and repair and so on, and have that to do the basics in the building, and then have this higher order optimization and things like that happening in the cloud or in some other level, preferably using these independent data layers in between, so that you can have like these service providers interacting, and building owners have the possibility of kind of picking what and with whom they want to work with, and change the service providers if they are not happy.
Yeah.
So something along those lines, I at least would hope that the future looks like. But yeah, there's still a few years of this kind of a crunch where we just need to get things done very quickly. Like,
exactly. Yeah.
any. It's a bit like nuclear power now. It's very it's a bit late to save the world by building nuclear power plants because it takes so many years to get one running. There's the same thing with these building systems that coming up with all these kind of super fancy things and making things even more complicated and so on. It's just going to take too long, and we just need to get cracking and come up with ways of getting the optimization into the buildings. Last week if you cannot do it last month. So
just being better with what we have already.
Yeah, absolutely. That's exactly like reuse, repurpose, retrofit the things we have now, and focusing on ways to scale it into the buildings that are not the sexiest and fanciest city center building blocks. The most of the carbon footprint is generated in these suburbs and so on, where you have buildings that are not so fancy, but they still could be optimized and could be or are the kind of the biggest kind of low-hanging fruit in reaching the net zero if we just all kind of focused on them.
Exactly. That's a great place to finish. Thank you so much, Ville. Thanks for your comments, and I really appreciate your time.